Okay, so today I will show you how I've created my first CNCed part, and it looks like this. And it's kind of boring, but it's only until you add all the components, starting with Arduino Leonardo, which usually looks like this, but it can also look like that. And since it's tiny, it can easily fit into this slot, keeping the USB port accessible from outside. The next piece to this puzzle is the rotor encoder, and this one is special in a way that it already includes the microcontroller, as well as 20 LEDs, and as soon as you connect it to the power, you can turn it and the LEDs will light up. Obviously, we still need to connect it to Arduino to get the value. And we will not use one rotor encoder, but 3 of those. The next piece is the acrylic glass cut into the shape that it fits into this enclosure without any screws. And I have a few versions, one clear and 2 slightly tinted. The last piece is replacing the default knobs with big and heavy aluminum ones. So what I ended up with is a simple controller for my PC. Let me jump back from the future and show you how it looks like when everything is soldered and put together. So now I can turn the knobs and the LEDs will light up, and of course it can control something on my PC. Now before I show you all the individual steps, let me tell you about the manufacturer of the CNC part and as well as the sponsor of today's video, which is a PCBWay. They not only offer PCB manufacturing but also the CNC machining and 3D printing, and if you use the link down in the description you can get some nice discount. Anyway, let's get back to the video. The brain of this controller is this Arduino Leonardo, and that's because it acts as the USB device, which means that you can send keystrokes or mouse clicks or some special events like setting the volume, which is something that I've already tried in my previous video. This tiny board has very small form factor, but unfortunately it doesn't have any obvious mounting points. And what's even worse is that the I2C pins which I need for my connection are on the bottom of the board, so I need a little bit of free space below the board. I've decided that I will create this kind of cutout into the enclosure, and I will just not mount it in any way, but instead press it with maybe some kind of rubber once I mount the rotor encoder above it. It's definitely not the best solution, but it works. This rotor encoder module is great because it does have mounting holes, but it also has the LEDs and the microcontroller which is responsible for lighting up those LEDs. So all that's left to do is to connect it to the Arduino using the I2C connection and read the rotor encoder value or the button click. There is this tiny little switch on the bottom of the board to set the I2C address, and you can use up to 4 modules at the same time. For the connection you can use this gravity connector, or you can use those pins on the right side. When you have this text on the bottom, the LEDs starts lighting up from the top, but since I want these LEDs to light up from the bottom, I need to rotate it by 180 degrees. This text will most likely not be visible anyway. What I like the most about those modules is definitely the documentation. The wiki page has all the necessary details as well as 6 examples for Arduino, and some of those even come with the small GIF file preview, like for example this one, so you can see what to expect. So this one is pushing the button to reset the values, the next one is setting the RGB values for the light strip using the 3 of the encoders, and there is also one for rotating the servo motor. So let's quickly try one of the examples, for example this one, which is for getting some basic information and especially the rotation value. For now I will be using the full-size Arduino Leonardo board because it's much easier to connect it to the module. Unfortunately we cannot use the provided cable because it has the female pins while we need male pins, so instead I will use a simple wire with male pins on one side and female pins on the other side. As for the actual connection, the plus connects to 5 volts, minus connects to ground, the C stands for clock, so it connects to SCL, serial clock, and the D stands for data, it connects to SDL, which is serial data. Again, once you have this connected to power, you can start rotating the rotor encoder and the LEDs will light up because it's being controlled by the chip on the board, not the Arduino itself. So once we have everything connected, we can jump back to the documentation. And that's because we need to download and install the library, at least that's what the documentation says, but if I open the GitHub page and jump to the installation part, it tells us that we can either download this library from here or we can just search the dfrobot visual rotor encoder library in the Arduino IDE, and that's what I will do. So I'll copy this name and jump into the Arduino IDE, and here I will select sketch, include library, manage libraries, search for this name and press the enter key, and hopefully it will find the library. And you can see that I already have this library installed, but if you don't, you have to click the install button and that will install it for you. Close the dialog and we can use a sample code from the wiki page. If you hover over the code, there is this small copy button. If you click it, it will copy the code into the clipboard, and then of course inside the Arduino IDE you just paste it, and the next step is to selecting the correct board. Again, in my case that's the board Arduino Leonardo, and the correct port, which will of course be different in your case. Sometimes the Arduino IDE shows the name of the board, which is of course helpful, sometimes not. Then we can click the upload button and upload this to the board. If you look at the code, all the data is sent using the serial connection, so in order to see it we have to open the serial monitor, clicking this icon and making sure that the speed is matching the set speed in the code, which is 115200. Then as you turn the knob, the number will change between 0 and 1023. Again, unfortunately you cannot choose which LED is lighting up first, so if you want to start at a different position, you have to simply rotate the whole board around. Let's also try the second example because that one is important in understanding how the encoder sets the value. So the rotary encoder rotates by a small steps, it's called a detents. By default, every small step, every small rotation of the rotary encoder means that new LEDs will light up. And just because we have 20 LEDs and the value could have 1024 values, it means that every small rotation increases the value by around, it says around 50, but it's around 51. So in this example, we are setting the accuracy to 10, which means that you need to rotate the rotary encoder by 5 detents instead, which means that you need to get a lot of more rotation of the rotary encoder to go from 0 to 1023, so you have a bigger accuracy. So one more time, copy the code into the clipboard and paste it into a new sketch in Arduino and upload it to the Arduino board. And you can see that now I need to rotate the knob a lot of times until all the LEDs will light up and I will reach the maximum value. And you can try also the other examples, but I think that at this point it's time to go back to the enclosure. And for that I'm using Autodesk Fusion 360, which is free for personal use with some limitations. For example, you can only have up to 10 editable documents at the same time, which doesn't seem to be too much of the limitation for me. And there is also a limited number of exportable formats, but you can export this in step file, which is the one required for manufacturing, so we are safe here. Since this was my first time using this application, I was kind of lost, but I've realized that I need to create a sketch, so I've created a sketch roughly around the size of the future enclosure, and then I've extruded this sketch by 10 millimeters, 1 centimeter, and then I've used the shell to remove the inner part of the enclosure, and then I've used the chamfer and fillet to make the inner parts around it. And it was at this point when I realized that it will not work. And that's because I don't really know how the components are big or small and how they will fit into here. So I really need to have those components first and then create the enclosure around those components, not the other way around. And since I wasn't able to find 3D models for any of those components, I had to create those by myself. So I've taken the caliper and started measuring the rotary encoder module and created a sketch like this. It's probably not super precise, but it's precise enough for me. Once this sketch is done, I've extruded the PCB board as well as the rotary encoder, which is slightly above the PCB, and then one more time for the rotary encoder handle, which I've chamfered a little bit. I've also created the rounded corners for the board itself, and then I've extruded the rotary encoder one more time, because the handle is quite big, and I've used one more chamfer for the top of the handle of the rotary encoder. I wanted to get this done as quick as possible, so I didn't care about the very small components. I've only cared about the components that are big enough so they can cause any trouble when putting this together. But that's the case for the bottom of the board. So on the bottom of the board there are also some elements, and those are those two connectors. So I've created a sketch with those two connectors, then extruded the first one, so this one is the big one, and also the second one, for which I've created another sketch with those individual pins, which I have also extruded to top, and then one more sketch with the side of the pins, which I have also extruded to the right side. It might not be the best way how to do stuff, but it was good enough for me. Finally, I've also created those small LEDs on top, although this is probably not needed at all. I just wanted to see how it looks like, but it doesn't affect the placement. You can see that I've also added this small triangle to show me where the top of the board is, because the connectors on the bottom are not symmetrical. And so this is the final 3D model of the rotary encoder module. I've saved it as a separate file and created a new file for the Arduino Leonardo board, which is called the Beetle. I wasn't able to find the 3D model, but at least I was able to find the image, which I've used as a reference, and it took me forever to find out that in order to set the image size, I have to right-click this image, select Calibrate, and then click 2 points and enter the dimensions. So this is 20, but I can change it to a different one if I want to. The next step was creating the sketch based on this image, and if I hide the image you can see that the sketch kind of copies the outline of the board. I don't really need the individual holes, but I've created those anyway, and I've extruded this sketch to create the PCB, something like this. The bottom of the board is flat, but on top there is this chip and the USB connector, so I've created another sketch and measured the position of those two elements. Then again I've extruded the chip and I've also extruded the USB port, and just for the visual purposes I've also added a little bit of chamfering for the USB port, so one chamfer on the bottom and one chamfer on the top. It doesn't look too much like the USB port, but the size should be the same. And so this is the final 3D model of the DF Robot Beetle board, which is the Arduino Leonardo based board. So it's finally time to work on the enclosure itself. So I'll create a new document and show all the other documents by clicking this show data panel. And I want to insert, of course, the knob into my current design. So I'll right click and select insert into current design, and it will be inserted on the origin, which I think it's fine for me. So I click the OK button, and now we have one in the middle. We want to have another one on the right side and one on the left side. So I'll do the same thing. I will right click and select insert into current design. But what I will do now is I will move it to the right side. So I'll drag this arrow, and the width of the board is 37 millimeters. I want to have a little bit of spacing, so I guess I will move it to 40 millimeters. So there is a little bit of space in between. I will click the OK button and do the same thing one more time, but this time I will move it to the left side. So I'll right click and select insert into current design, but this time I will move it by minus 40 millimeters or by 40 millimeters to the left side, like so. Click the OK button, and now we have 3 knobs in our design. I want to also insert the beetle board, so I'll right click the beetle board and select insert into current design, and again this will be inserted at the origin, which will of course intersect with the other board. So I will change the view slightly, like so, maybe to the front view, and move it more to the bottom, maybe by 5 millimeters or so. I click the OK button, but if I show it from the bottom, you can see that the placement is not right, because I want this board to be a little bit outside of the other boards, so the USB port is sticking out. So I will select this board, the beetle board, and select modify, move, and then move it more to the bottom, or actually outside of the current view by maybe 12 millimeter. Click the OK button, and if I show it from the top, you can see that now the USB port is sticking out, which is exactly what I need. Now I want to create the enclosure based on the size of those 3 knobs, so I will select the measure tool and measure it from this line to this line, which should be 117 millimeters. And I already know that the height of the board is 37 millimeters, but just to double check, I will select the measure tool one more time and measure this distance, which is 37 millimeters. So let's create a new sketch in that size. So I'll click this, which will create a new sketch, and I need to select the plane or face, and the easiest one to do is to hide those components, because I want to create a new plane on this axis. So I'll click this plane, and it's asking me that I've already moved some components, and if I want to keep those positions, and of course I want to keep those positions, so I'll select capture positions, and that will create me the sketch in which I want to create a new rectangle, but the rectangle will be the center rectangle. I want to click the center part and then insert the dimensions, which are 117 by 37 millimeters. Click the OK button, and that should be the size of all the 3 knobs next to each other. If I show the knobs, you can see it's matching the knobs. Of course, I want the enclosure to be slightly bigger, maybe by 6 millimeters or so. So I will select modify offset, select the rectangle, and offset by 6 millimeters. Click the OK button, and this will be the outside size of the enclosure. I will select finish sketch, but if I show it from the front, you will notice that the sketch is at the origin, while the components, the knobs, and as well as the beetle board is sticking to the bottom. So I want to select all the components by clicking on those with the control key pressed and move those slightly to the top. So I will select modify, move, and move those maybe by 7 millimeters, because I want the bottom of the enclosure to be 1 millimeter thick. So there should be at least 1 millimeter between the components and the bottom of the sketch. I will click the OK button, and we can probably extrude the sketch. So I will show it like here and select the sketch, and then click the extrude button. Again, it's asking me if I want to keep the positions. Of course, I want to keep the positions, and I will extrude both rectangles. So I'll click both rectangles by 1 millimeter. Click the OK button, and now we have a base for our enclosure. Let's create the support for the beetle board. So I will create a new sketch on the top of the enclosure. So I'll create a new sketch and click this plane. So that will create me a new sketch on top of the enclosure. Then I will rotate the view to have the board on the top, and I can hide the knobs because I don't want to see those right now. I only want to see the sketch and the board. So what I want to do is I want to create some kind of support on which the board will sit on. So what I will do is I will create a new rectangle, a 2-point rectangle in pretty much any size. So I'll just draw it without specifying the dimensions, and I want to align it on the top of the enclosure. So I'll select the midpoint constraint and click this line as well as this line, so it will align it, and I will sketch the dimensions. So I'll select sketch dimensions, and for the width I believe I was using 24 millimeters, so it's slightly bigger than the board, and for the height I believe I was going with 19, so I will sketch the height as well, and that will be 19 millimeters, so it's not all the way to the bottom. However, I also need a hole in this piece so I can get to the bottom of the board for the I2C connection. So I'll draw another rectangle, again in any size. I will not specify the dimensions right now, but instead I will select this midpoint constraint, and I will click this line and this line, so it will be aligned to the bottom of the previous rectangle. And then again I will sketch the dimensions, and I believe that for this one I was going by the width of 12 millimeters and the height of 12 millimeters as well. So I will sketch the dimensions for the height, and that will be 12 millimeters. If I select, only this piece will be extruded. And we can actually do this by clicking the finish sketch, keeping this piece selected and clicking the extrude button. And I want to extrude it by 1 millimeter, and I will make sure that the operation is set to join, so it will be joined with the bottom piece. Click the OK button, and now we have a little bit of support for the board. If I show it from the back, there should be a hole below the board, so I can hopefully get some wires in there to get to the I2C connection, I2C pins. I want the support to also include this zigzag pattern so the board can snap into it. So I'll create a new sketch that will be based on this plane. So I'll click this plane and again rotate the view. But this time maybe switch to the 3D view, because what I want to do is I want to project this piece or project this shape onto our sketch. So I will hit create, project include and click project, and I want to project this piece. So once this is being projected, click the OK button and I can hide the 3D model, and now I have those shapes projected into my plane. I can even hide the bodies so you only see the sketch. I will switch back to the 2D view and I want to extrude this part, but of course without the USB connection, and also it could be slightly smaller. So I will select modify offset and select this path and offset by 0.5 millimeter, so 0.5 millimeters. Click the OK button and then we'll create a new rectangle, again in any size. So I'll not specify the dimensions and align it to the top of the sketch. So select midpoint, this line, and then sketch the dimensions, and I believe I went with like 9 millimeters for the width. And pretty much any value for the height. The only requirement is that it's intersecting with the arrow piece, so I'll make sure that it's big enough. I will finish the sketch, switch back to the 3D view, show both the bodies as well as the beetle, and then extrude our new piece. So I'll click extrude and select this piece, and I will also extrude it by 1 millimeter and make sure that it's joining the current body. Click the OK button, and now we have much better support for our beetle board. Let's also extrude the outline of the board, so I'll create a new sketch, so click create sketch and select this plane. And I will select modify offset and offset this by 4 millimeters. Now remember, we previously offset by 6 millimeters from the size of the knobs. So if I offset by 4 millimeters into inside, there will be still a little bit of free space around the knobs. So click the OK button and we can hide the knobs for now. And the thing is that we don't want to extrude this part, so this part around the beetle board. So what I will do instead is I will draw some helper lines, and actually let me hide the body so it's not getting in our way. And I will select the line tool and simply draw a line from here to here and from this side to this side, which will separate the piece that we want to extrude, which is this piece, from the other piece. So I'll select finish sketch, switch to the 3D view, show the bodies, and I will extrude this part. So I will select extrude this part by 2 millimeters, so it's on the same height as the support for the board. Now I want to keep extruding, but not this inner part, so I'll create a new sketch, so create sketch on this plane. And in a very similar way, I will also try to separate the outer part from the inner part, and that is by drawing a line. So there will be a line from this edge to here, and there will be another line from this edge to here. Again, finish the sketch, switch to the 3D view, and we can keep extruding. And that's of course by selecting the extrude, selecting this part, and I will extrude this by 12 millimeters. Now this is not just a random number, because if I switch to the back view and maybe switch to the wireframe view, so select this icon and set the visual style to wireframe and then show the knobs, we want to make sure that the enclosure gets above the rotary encoder base, which is the case in here. It could be probably a little bit taller, but I felt that it's already very tall. The knobs are still floating above nothing, so it's time to add some support for those. We will start with a new sketch that will be based on this face, this one, and we want to project those individual holes to this sketch. So we will select create project include and then click all those individual holes. And once we have everything selected, click the OK button and we can hide the individual 3D objects as well as the bodies, so we will end up with just this sketch and those holes projected onto the sketch. Now we want the support to be bigger than the hole, so what we will do is we will create a new circle in the same position as the hole, and this could be, for example, 6 millimeters in diameter. Now what I've done previously is I just extruded this part, so I just selected this, extrude and extruded all those both circles to maybe like 5 millimeters, but then I realized that this part might be hard to machine. Even if I add a little bit of fillet to this part, it will still be hard for the tool to go into this section. So what I've decided instead is that I will connect this support together with the outer shell. So let me just undo a few of those operations and jump back to our sketch. And what I will do here is I'll draw a helper line. So create a new line that will be connected from the circle to the outside, like so. And then what I will do is I will select the constraint that will be the tangent constraint. So I want this line to be tangent to the circle. So the line should be tangent to the circle. And then of course this line should be horizontal or vertical. So I will select horizontal / vertical and click this line, and that should fix it. And I will do the same thing for the other line. So again, it should be touching the circle and the outer part. And then I will select tangent for the circle and the line, and the horizontal vertical constraint for the line as well. So that should fix it. So this is one type of support. And there is also a second type of support where the two holes are next to each other, for example, like this. And we want to use the very same shape, but those holes should be connected into one. So what I will do is I will create a new circle in the same position as the hole in the diameter of 6 millimeters. And then I will create a second circle, 6 millimeters. Then I will connect those two using the line. So again, I'll create the line from one to the other, like so. And then use the tangent constraint, but this time it will be the tangent between the line and the left circle, as well as the tangent between the line and the right circle. Then I'll create the second line that will connect the circle together with the outer of the shell, like so. And again, apply the tangent constraint to the line as well as the horizontal vertical. And I'll do it one more time for the right side. So line between the circle and the outer part of the shell, apply the tangent between the line and the circle, and the horizontal vertical constraint, like so. Now we have more holes in our sketch, but since everything is symmetrical, I think that we can mirror it to the right side and to the bottom side. And for that we need some helper lines, so I'll create a new line and I will draw it as a horizontal line on the origin, and then I will select the line, so I will click the escape key to stop drawing. I will select the line, like so, and in the sketch palette I will turn this into a construction line, and I'll do it one more time for the vertical line, so vertical line on the origin, like so, escape key to stop drawing, and select it and set it to construction line as well. Then I will select create mirror, and in here I want to select the object, so I'll select this line, circle and line, and those three lines and two circles. I will switch to the mirror line and I will select this vertical line, so it will mirror it on the right side. And it doesn't let me do this, and I think it's because this line was already selected for the object, so I have to switch back to object and make sure to unselect this line and then switch to the mirror line and select this line again. And now it should be working. So I'll click the OK button, and now we can do it one more time for the bottom part of the sketch. So I'll click create a mirror and again select all those objects, so line, circles. Then click the mirror line and select this line, and it should be mirrored to the bottom of the sketch. Click the OK button, and I think that we are fine. So I will finish the sketch, switch to the 3D view, and we can start extruding. However, we first want to know how much we want to extrude those supports, and for that I will show the knobs, and I want to measure the distance between the floor and the knob. And I can do it right now by going inspect measure and then select this bottom floor and one of the bottom piece of the knobs, like for example this one. And you can see it's 6 millimeters, but it's kind of hard because there are so many elements. So probably a better way would be to use the section analysis. So I will select inspect section analysis and then hide the knobs temporarily and select this plane, show the knobs. And now I can move this section analysis until I see a clear distance between the knob and the bottom of the floor. And now it should be much easier for me to select those individual planes. So select inspect measure, and now it's very easy to select this bottom floor as well as the bottom floor of the knob. And again, you can see that the distance is 6 millimeters. So I will hide the analysis by clicking this eye icon. I will also switch to the top view because I want to see all those individual holes, and temporarily hide those knobs. I will also close the measurement, and now I want to extrude those pieces, so I'll select extrude and select those individual pieces. So this one, those two, and continue like this for all the other pieces. As we mentioned already, the distance should be 6 millimeters, and that should be it. If I show the 3D view, we now have supports for those individual knobs. And if we show the knobs as well as the section analysis, we can move the section analysis by right-clicking the section one and select it, edit. We can move it to the point where the board of the knob is touching the support, like so we can see that the distances are right. Now, since the boards of the knobs include holes, it might be a good idea to add a threaded hole into the enclosure so we can use screws to put those together. So what I will do is I'll create a new sketch on one of those islands, and then I will project all the other ones. So I'll select create project include and then click all the individual islands to include those in our sketch. Hit the OK button and it should be part of our sketch. Then finish the sketch and switch to the 3D view, and we can start adding holes by clicking this hole button. So click the hole button and start clicking those individual points, like so. So here is another one, here is one point, here are the points. And you can see that right now the holes are going all the way through our enclosure. So we will have to adjust the depth a little bit. I already have the preset from the previous settings, but I believe that by default this is not set to simple. I want to set it to tap hole, and I want to use the isometric profile of the size of 3 millimeters. And the depth could be, for example, 5 millimeters, so it's not intersecting all the way through our enclosure. Keep all the other settings as default, hit the OK button, and now we should see the holes inside our individual islands. pins, so those could be used to screw individual knobs to the enclosure. Now we are already done, but I feel like everything is very rectangular. I feel like that we can round some of those edges. So I'll select the fillet tool and select the inner edges. So this one, also this one, and those two. And I'll set the radius to 4 mm. Now it might be a good idea to switch to the top view and make sure that the knobs are visible so it's not intersecting, but it doesn't seem to be the case. And we of course want to round also the outer edges. And if you want to keep the same width of the edge, we have to do a little bit of calculations. So I'll select inspect measure, and the thickness of the wall is 4 mm. And since this inner radius is 4 mm, we have to use 4 plus 4, which is 8 mm for the outer radius for the fillet. So I'll select the fillet, select the outer edges, so those two and those two, and set the radius to 8 mm. So that should keep the wall in the same thickness. In a very similar way, we can round the supports for the knobs. So I'll hide the knobs, then select the fillet tool and select all those connections between the islands and the outer shell. And you can experiment with the value, but I believe I was going with 4 mm. So this not only looks nice, but I think that it should be also easier to manufacture because there are no sharp edges. Now we still need some kind of rim, so we can then put the acrylic glass on top of it and it will not fall off. So I will create a new sketch on top of our enclosure, selecting this face, then hiding the body, and we want to offset the outer shape, but you can see this one is not continuous, so instead I will most likely create a new rectangle. But before I do so, I have to measure the size of this shape, so I'll select inspect measure and measure the width of the shape, which is 129 mm, and then one more time for the height, which seems to be 49 mm. I want to offset it by 1 mm, so I'll create a rectangle smaller by 2 mm on both sides. So I'll select create a rectangle, the center rectangle, and the dimensions should be 127 by 47 mm. Of course, I need to round the edges, so I'll select modify fillet or click this icon on the toolbar and then select all the edges so it's being filleted like so. And since the outer fillet is 8 mm and this one is offset by 1 mm, it should be 7 mm for all the fillets. Click the finish sketch, show this into a 3D view and also show the body. And we want to extrude this outer part, so I'll select extrude and extrude this part. Let me actually zoom in a little bit more so I can select it properly. And that should be extruded by 2 mm. So we have a little bit of rim for the future acrylic glass piece that will be put into this enclosure without any screws or without any mounting points. I've also decided to add a little bit of chamfering to not have sharp edges, so select modify chamfer, and I believe that for this edge I've added like 0.5 mm chamfer as well as for the bottom part of the enclosure. So again modify chamfer, and for this one I've also added 0.5 mm chamfering, and then for the very top of the enclosure for this line I've also added the chamfer, so modify chamfer and select all those individual lines, so as well as those two and those two. And I've added like the smallest possible chamfering of I believe only like 0.1 mm. Not quite sure if that makes any difference, but it surely looks a little bit nicer. And I think that at this point the enclosure is finished, so we can export it. So I'll jump to File, Export, and select the step file for exporting, which is this one, and of course export it somewhere. So I click the export button, and it will be exported right away. Then jump to the PCBWay website, select CNC 3D printing and select CNC machining, and here you can upload the exported step file. And once you do it, you can see a small 3D preview, and if you click this icon, you can actually see it in 3D, but the 3D viewer it's not perfect, so you can see that the inner part is quite hard to see, but you can at least see that this is our model. So I will select one unit, and I want to get this done from aluminum. I will go with the default one. I want to have a surface finish, so I'll click this arrow, and there are way too many finishes to choose from, but one more very common finish is the anodized combined with the bead blast, which means that the finished piece will be first blasted with beads, and that will make it a very smooth and matte appearance, so there will be no sharp edges, and then it will be anodized with color, and there are around 12 colors to choose from, but I'll of course go with black because all the other components in this setup are black as well. So select submit, click the OK button. Of course it's just saying that it has to be somehow held when it's being anodized, so there might be slight mark, but I don't care about this that much. So click the OK button, and if I scroll down there are quite so many options to choose from, but probably the only thing that I want in my piece is to have holes so I can then use screws. So I have to select I want to have holes, but it's asking me to add the technical drawing, which I don't have. So what I have to do is jump back into the Fusion 360 and somehow create the technical drawing. So click the design button and select the drawing from the design, and we can select some options, but I think I will go with the default ones. So I'll click the OK button, and that will create me a new technical drawing document. I want the default view to be from the top, so I'll select top orientation, and I want the scale to be 1 by 1, so select 1, and then click to place the current view, but I also have to click the OK button, and that will place me the default view. I will zoom in a little bit, and I want to add a note saying that there will be 12 holes for the M3 screws. So what I will do is I will click this text, the note text, and click any of those holes, and it will automatically populate me with all the information. So there are 12 M3 holes, and I don't think that I need to do anything else. So I just need to export this drawing, and here comes the problem. If I go to File, Export, you can see that the export option is grayed out, and if I click this button on the toolbar saying the export, if I click any of those options, it will say me that I need to get the full paid subscription to be able to export the drawing. So at this point I can most likely capture the screen, like take a snapshot and save it as a JPEG or PNG file, but what I can also do is I can just print it, but instead of printing it to the printer or sending it to a printer, I can print it as a PDF file instead. So go to File, Print, and instead of selecting your default printer, select the Adobe PDF if you have the Adobe products installed, or Microsoft Print to PDF if you have Word or Office installed. Then click the print button and it will show you the file save dialog where you can specify where to save your PDF file. And then you can of course use that file for the technical drawing on the PCBWay ordering. Now currently the page shows that the price will be $47, but there is a note saying that the price might change after someone will actually look at those parts, and it actually happened. After I clicked the submit request, the price went up to $55, but I think that this is still a fair price for this enclosure. Or in other words, I don't think that you can get it much cheaper in a different place, but if you think that you can, please let me know in the comment section. So after a little bit of waiting, here is the final piece, and I can say that I'm pretty satisfied with the result. There are some visible tool marks, but only on the inside where I don't care about those at all. To keep those encoders in place, I have used those small plastic screws, and it actually stays nicely secured even if I used only one screw per unit. Here is a quick test with the knobs installed, and then of course it was time to solder everything. I have only used black wires because, as you can see, those wires are visible in the gaps between the knobs. I was worried that it will be confusing, but it wasn't actually a problem because there are only few wires being used. To keep the Arduino board in place, I have used this transparent double-sided tape and put a few of those pieces in between the board and the enclosure, as well as in between the board and the knob. And so this is the final piece. So turning the knob will change the LEDs as well as send signals to the PC. There are of course some things that I would do differently if I would do it again, but I was pretty happy that I was able to finish it, considering the fact that it was my first CNCed part as well, first time using the Fusion 360, so as always it took me more time than I was thinking it will take me. Anyway, thank you very much for watching my video. I hope you've learned something new. If you have any questions, please put those down in the comment section, and I hope to see you next time. Thanks and bye.